Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about 240 watts on USB-C. So let's dive right into it. Now first we have to understand what exactly is the problem. Now the problem is 100 watt that USB-C power delivery has. Be mindful, USB data and USB power delivery, they are two separate things. That's why USB-C is an independent entity. That's why you can find USB-C in USB 2.0, USB 3.0, USB 3.1, 3.1.1, 3x into 3x, blah blah blah. You get that point, and that should be coalesced into one in USB 4, where there's like no, USB 4 equals USB-C. So that has not happened yet. So be mindful, when I'm saying 100 watts, it does not mean your normal average USB-C charger should be able to provide that. So even if you buy an adapter that has 100 watts of power delivery system, now again be mindful, when they are claiming 150, they are claiming of the whole unit. So generally one cable can barely give you 100 watt. Like if you are really lucky, 120, it will not give you 150. Now whenever you buy units that are claiming something like that, they are generally meaning we have 3 ports, you can divide it however you choose. 100 watt is just not enough. So fundamentally we are reaching a point where we want our mobile phone to charge in 1 second. So we are in a point where we are actually manufacturing equipments that are pumping almost 150 watts of energy into a goddamn mobile phone, because we are just so goddamn impatient. But you get that point, like if there is a demand, there will be a supply for it. So that creates an issue. That power delivery standard, while it was like very far thinking, where it's like no, it should be able to take care of things, it failed miserably, because even mobile phone exceeded it. And when it comes to laptops could have very varying amount of power demand. So you could have a scenario where it's like you connected the laptop and 100 watts is more than enough, but the moment you start to load a game, it's like, yeah, the GPU spikes, and it's like, oh, it's gonna drain the power directly from battery to compensate for that lacking supply. And that's really bad, because that simply means if you're playing a game or doing something like that, you will have a scenario where the battery is going charging and discharging while you are playing the game, even though you are connected to the system. So it's really bad. So in those sort of scenario, laptops simply cannot rely on 100 watts of reliable power. They need more than 150 watts of reliable absolute power. So gaming laptops, now you may be like, who cares about gaming laptops? It's not a real thing. No, it's a real enough, more than enough people spend money on it, and it's a big deal. On top of that, workstation laptops, meaning laptops that have Quadro series of graphics card, things that are used by either engineers, architects, or animation industries, those do consume a lot of power. So you are talking at least 160 or even 200 watts of power. Without it, don't even think about them. And USB implementation firm, they are thinking far ahead this time. They are like, why we are limiting ourselves just to electronics? What about power tools? For example, you have if you are familiar with basically power tools which have the battery packs, they have generally surprisingly low voltage, meaning you have 18-volt battery packs, you have 24 volts, some have like ludicrously high 48 volts. Generally they are very low in terms of voltage wise. Some are there that are like very high, but generally 48 is more than good enough. Like if I say 48 volt system, most of the companies, most from Bosch, from Milwaukee, from other companies, most of them will be below this. So fundamentally, why not charge them also? But again, you can charge them at that voltage, but problem is that you also need to provide a lot of amps, because if you're gonna go to them, it's like, hey, can you work at 100 watts? They're like, dude, not fast enough. So this time 240 watts, that's like GG. At that point, it's like more than good enough. And even e-mobility is also considering, meaning if you let's say have electric bicycle, even a motorbike can be charged, but very slowly. Be mindful, this is a slow charge kind of situation. It's not something, it's like quick full charge GG. It's not there. It's no longer it's no longer trying to compete against CCS charge standard. It's just like e-mobility, meaning you have one wheels, you have electric skateboard, things of that nature, which allows you to move from point A to point B, but does not consume kilowatts of power. It's like you can easily charge it at 200 watts per hour. So those sort of things also should be considered inside this. Now the aim of USB is just to become that universal. Now that simply means that one charger needs a lot of power. That's why you do not want to ever see something like this. Generally these puppies are rated for around 60 to 80 watts, and the biggest problem in that is, like, even though people may have an illusion of saying, hey, barrel connectors are standard, no, they are not standard. They have multiple sub variation, meaning of diameters, inner diameter and outer diameter. And then also you have some scenarios where are really difficult and dangerous, is that outside or inside have different polarity. So in one system you'll have like negative on the outside, another you'll have positive on the outside. It's really bad, and if you cross plug them, poof. So this is a serious trouble for our world. Now there are some limitation of physics that you have to understand it. Now you may be like, okay, let's just increase the current. Why can't you? Well, there's something known as cable, meaning, for example, this is a basic garden variety USB cable. you can understand that inherently this puppy cannot take too much power. Now to give you a context of that, what you need to carry some serious amount of power, I'm just showing my, basically extension that I built long ago. Now, this puppy has three-phase power. It was like basically cable that was designed for submergible. Basically, it has 3 core, and this can easily carry a few kilowatts of power, meaning 2 to 3 kilowatt. This cable is like, bro, I don't even care. Now, this is powerful. Consequence, it's fat. It's fat AF. And it's very difficult. It's not pliable. It's not something I can put in my pocket. So there is limitation of how much amps you can use, and not to mention plug also becomes huge. So there is a limit to amps. You can't just go YOLO on it. Another aspect, then you will like, okay, we can't increase the amp too much. How about voltage? Well, you can increase the voltage, and we have been increasing the voltage, but there is a limit. If you exceed a certain point, meaning generally people are saying it's around 40 volt AC and 60 volt DC. If you cross that threshold, you are in what we classify as shock hazard territory. It means if you do not have a lot of dead skin on top of you and you touch the terminal, you poof. You do not want to go poof. So it's a really serious shock hazard, and that's why even automotive industry, basically you have your vehicles, they are moving from 24 basically 12 volt system to 48. Why the heck they are not going to 60? That's the same point. They want to make sure that sub battery, meaning the batteries that are driving your anti-lock braking system, the power steering, air conditioning, everything, every electrical load other than driving the damn thing should be done at much higher voltage, benefit reducing the ampere. In those scenarios, they are trying to reduce the ampere, so the cable becomes lighter. Lighter the cable, the lighter the total vehicle weight, more efficient. Awesome. But that's why they are also limited at 48 volt. They are not going, for example, electric vehicles can easily have battery packs that are like 200 volts or even 400 volts. That's not safe, and you can see that. Like you can see, watch any Weber YouTuber university show where they are opening up EVs and the cables are thick. Insulation on them is even thicker, and then they have shielding, and then they have more insulation to make sure that this puppy is safe. You do not want to have that on your puny USB cable, that you have one layer of insulation that is primary voltage, then you have grounding shield, then you have another insulation. Yeah, that's not feasible. So that's why voltage is also limited. From a realistic safe point of view, people expect generally 50 volt DC should be good, meaning if a child chews through it, it should not go poof. So that is the whole point. It's safe, quote unquote safe. Again, still serious amount of energy we are talking about, but should be safe. Do not put it in your tongue, you will lose your tongue. And 5 amp should be manageable. And amp also have another side effect. Amp is directly proportional to heat generated into the system. So that's why you can easily notice that, like if you have a basically heating element, generally they rate themselves in amps. Amps is directly proportional to how much energy you are thermal loss, quote unquote. So you really don't even want amp to be too high. So this is the reason why you have such an awkward rating. It's like why at 240? That's the whole point. 48 volts at 5 amps, that's the maximum they can do. And they wanted to push it to even more, but they are like, yeah, governments are like, bro, if you go that high, you have to give mains insulation on almost every cable. That's just flat out unacceptable. Like, again, it's acceptable. It's like cable cost will go too high, and like these cables are displaceable things, meaning you will wear through them multiple times. So not acceptable, meaning too much waste created. So, and there is another side where the moment you start to go above 5 volts, 6 volts, something like that, you start to create architecture. This image I'm pretty sure most of you have seen in the internet. So that also creates another problem. You have to have some sort of snubber circuit. Now that snubber circuit could be an analog circuit, meaning a physical device where you have resistor and capacitor in series to make sure that you go yoink, it does not create an arc to destroying your devices. That can be done, or it could be done by the microcontroller. It's like, whoa, you are disconnecting it. Disconnecting is the issue, because the moment you connect it, it does not directly dump 240 watt. It waits, it creates a handshake. Once it has the handshake, then it unlocks the power. So it's safe during connection, but when you're pulling it out, yanking it out, it's a very dangerous at that point in time. So it also needs a bit of power delivery management. That's why you can't just upgrade your old equipment with a firmware. Even though you can do the handshake thing, if you do not have a proper snubber circuit, poof. So that is an issue. So these are physical limit. They cannot go beyond this at this point in time, unless they are willing to push something very significant. I'm only expecting them to able to go from 5 amps to maybe 6 or maybe 10 amps. But the cable will start to become thick. It's like, whoa, this is some thick boy cable. If you start to push that kind of amp voltage, again, they are already pushing at 48 volt, which is like really close to lethal limits. So there are some actual limits in physics. Now, handshake is also another thing that we have to deal with. At this point in time, I tried to read through the documentation of USB implementation for basically USB power delivery 3.1. it's hundreds of page long, and it has full-fledged data communication. It's no longer like, dumb scenario where you have like in electric charging station where it's like, oh, based on resistance it can figure out like how much you need. No, this is like a handshake. It's like almost a MIDI communication where it's like, if bit 1 is on, okay, then you are sending power in this voltage range. If MIDI power 2 is like, it's like a complete handshake, meaning you have to buy microcontrollers which are expensive. And you will notice that like you will find many power banks that are very cheap, but they still do not give you too much power output. Why? They have to buy microcontrollers. Everything else is mass produced. These puppies are not mass produced yet. So even getting 100 watts of power delivery is very rare. That's why only few power banks have that. These are expensive, and trying to go to 240, these will become even more expensive. This is just a demonstration video which I have provided the link down below. You can check out, like, and they have like a connected oscilloscope, and you can easily see like in the beginning is like a lot of handshake is happening. It's like tuk 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 is sending the bit data, and based on that, then the sync device, meaning the recipient of the power, is like, okay, I want this is much. So this is a very complicated thing. At this point in time, it's no longer like, very old YouTube videos where you're like a linear regulator, a USB female jack, done, go home, sweet dreams. It's no longer that simple. It's far more complex. And it also has 3 charging subcategories, meaning it could be fixed voltage charging. I'm giving you this amount of power, deal with it. Then it could have programmable power supply output system, meaning you're going to have a much more loving talk with each other. It's like how much voltage, how much amp. Then you can have adjustable voltage supply. This may be desirable for some systems where you have, let's say, your battery voltage. I do not know exactly how they're implementing it, because I told you the 600 page documentation, and I'm not an engineer, so I can't read that. I'm like, I can read that, it just does not make sense. But what I'm expecting is that this should allow them to direct charge batteries, meaning your laptop should only need to have a BMS, quote unquote, and a safety circuit where it's like overcharging, done, discharging, done. So safety circuit, but because your lithium ion pack voltage could go up and down a lot. In those sort of scenarios, you're like, hey, give me this fixed voltage and start to reduce the voltage once you go from constant current mode to constant voltage mode. I inverted it, constant voltage to constant current. Once your lithium cell is fully charged, you want to drop the voltage. At that point in time, AVS protocol may be utilized if you are doing direct charging, meaning the charger is directly doing the charging and the laptop only has basically safety features built into it. That can be done. These are 3 modes, and I'm pretty sure they can work in concert with each other, so they're far more complicated. So this microcontroller is a serious thing. So do not expect, even though you may have a power bank that is like almost 100 watt hour capacity, or maybe those Jackery power banks, those are huge powerful, as in like multiple kilowatt. Even then, do not expect to have 240 watt output anytime soon, because the microcontroller is expensive. And I do not think I have to mention the silicon shortage that we are going through. So do not expect this puppy to be implemented anytime soon. Now, then we come to the greatest sin of all, bad naming convention. It's like, I genuinely do not know how the heck they can be that dumb, or they have a freaking engineer in charge of this. It's like, you do not put engineers in charge of some things. Like, engineers are awesome at building things. They are really bad at marketing normal things to normal people. They'll make even normal things overly complicated. So USB Forum have made bonkers move with USB 3. They tried to rename that puppy 3 times grand total. First name, second name, third rename. Dude, you have made the product, you have shipped the product. How the heck you are expecting to change the name? No, we're just gonna lol it. Yeah, that's a bad idea. So that fundamentally, think of it this way, like USB-C has an independent power delivery standard. Okay, awesome. This is power delivery 3. Again, do you even know what was 1 or 2? No problem. Okay, power delivery 3, awesome. Here's the, why it has 0.1? It's a brand new system. Why the heck it already has 0.1? That's the whole thing. It's fundamentally complicated, and it also has power and data as an independent training. Meaning, if you read a cable that says 40 Gbps, what does that mean? That simply means it can transfer basically data at 40 Gbps. You can read a cable that also says 20 Gbps. That simply means that. How much power it can transfer, you do not know. It could be good enough cable where it can transfer 100 watts of power, but you do not know whether it will transfer 100 watts of power or it will transfer 200 watts of power. You do not know. So you need this another stamp for 240 watts. This is ludicrously frustrating, and it will cause a lot of confusion, because a manufacturer can, let's say you are creating this new standard. He may be like, hey, my USB cable is a proper USB 4 cable which can do proper power delivery. But it does not know, like, and how many of you are actually going to remember you're supposed to read for 240? Because again, you have a symbol, then you have a logo, then you have blah, blah, blah. You can't have it all. So that creates fundamental issues. Like, in contrast to this USB mess, compared to PCI Express. Like, think of this way, like if USB Association renamed this puppy, it would be like USB 1.x, 1.2x into 2x, 1.6x. It's like, no, you just simplify everything. Simplify as much as you can. 1x, 4x, 8x, 16x. Same goes with basically these puppy, lithium ion cells, basically lifeblood of our world. How they mention it? Because there could be multiple standards, and there are multiple standards. 18650. What does that mean? 18 is the diameter, how fat this puppy is. 65 millimeter tall. Done. Go home, sweet dreams. The name simplifies everything. They could have simply said, if cable would have a simple rating, 40 to 40. Like that complete number would be super easy, because you cannot misplace that. It's like the number, and it could be even simpler like that, like 20 100 20 100. You get that, like, okay, 20 is the data and 100 is the power rating. But because they have two independent logos, good luck trying to find this complex logo. Good luck. So that's why, like, think of it this way, like, this is 18650. Now you may say, oh, this was a lucky. No, after this puppy they made an even fatter puppy for Tesla cars, that is 2170. What does that means? 21 is the diameter, 70 is the millimeter in height. Then if you have familiar with Tesla's battery day, they started a huge as cell, that is 4680. What does that 46 mean? Simply diameter, 80 is the height. Simple. That's how you do naming convention. Basically, the name itself should signify what exactly you're doing. This is garbage. This is fundamentally creating a lot of e-waste, because you may buy cable, and how do you buy cables on Amazon? You buy cables based on the prices, but if the logos are not clear, how the heck you will understand that this manufacturer is giving you power delivery? They both will say power delivery, but do you know that power delivery is supposed to be 3.1 or 3.0? So that's the issue. This is really bad naming convention again. So what we can expect in the future? Well, EU recently are going through with that common charging standard. Now be mindful, if you pay attention to this documentation, they should have mobile phones, tablets, digital camera, handheld video game consoles, portable loudspeaker and headset, but they do not have laptops. Now, is that mean it's a fail? Yes and no. Now, I do not blame your opinion, because it is a bureaucratic system. It will take years to do this. So I do not blame them. And not to mention, USB is universal standard now doing this. So this puppy was in the books for 2 years ago. So I understand that. That being said, but if the mobile phones and tablets, they start to utilize power delivery as fast charging standard, companies will literally push it to 150, and the moment that 150 watt limit is crossed, the end, most companies will literally start to use power delivery in their laptops, because it makes sense at that point in time. Think of it this way. Let's say you are Samsung, you are making laptop and mobile phones, and you want to do speed charging. Would you rather develop multiple different things, or you just like, hey, can you just increase the order of one device? It's much cheaper. It's much cheaper to go to one contractor and it's like, hey, can you just, instead of selling us like 500 million units, 600 million unit. That's much cheaper, much more efficient. One point of import and export, much more efficient. So the moment fast charging in mobile phones actually is forced, that's the interesting part. This time they are like, no, we see Android what you are doing. Every company is creating their own dash charger, warp charger. My last video was about that. No, you have to use power delivery. This will give it a huge boost. The moment you crack that 150 watt power limit, most laptops will simply change. Other laptops may require some love, because especially some laptops that require 200 watt plus power. Now again, 200 watt plus means your adapter must be able to sustain 210 watts of load. So that does require a bit of love, but doable. That will make it far more appealing to every manufacturer. On top of that, what will happen from Planet's point of view is that once you reach a point where everything is standardized, companies have to compete in different ways. And which companies I'm talking about? Texas Instruments, I'm talking about microchip manufacturers, I'm talking about ON Semiconductors. These sort of company, how will they differentiate their product with other companies? Right now they can just like, hey, I'm cheaper, or maybe like, hey, I can work with you, or like your weird guidelines like Apple has. That's okay, but like, what could be better? They will all have to compete in one very critical factor, that is efficiency. Meaning right now you can have very efficient buck boost converters. Those probably are around, let's just say 94% efficient. Now some company will like, hey, that company cheap, but they are selling you 94%. I'm giving you 96% efficient. Now you may be like, does that really translate to a much? Short answer, absolutely. How many laptops do you think are there on this planet? And what do you think will the power impact would be if, let's say, laptop adapter starts to have better power factor correction and better efficiency? Huge impact. So that's awesome. That USP, that the fact that efficiency will become a USP, is really desirable for all of us. And it will truly start to become universal power plug. Meaning, think of this, let's say you are traveling. How many things you carry with you that requires more than 200 watts of power? Let's say how many things you can manage in around 200 watts of power. If you can do that in 200 watts of power, Done. Like instead of carrying like weird adapters that is like attaching things, which still, mind you could have a scenario where you both countries have same voltage from your destination and your home, but they have different frequency, 50 hertz or 60 hertz. Boom, happen. When that happens, you could have a scenario where it's like plug fits, but it's like one is 110, another is 220. You could have like both have 50 hertz but different voltages. So that's why you want something that is universal. USB-C, this puppy could reach that. That is amazing. I'm really happy with that. And it could also reduce proprietary charges and e-waste and garbage and all that jazz, which I'm reasonably sure if I ask all my viewers, at least one or two of you would have suffered with that. Like my laptop is awesome but my charger broke, and replacement charger was too expensive, or worst case scenario, the laptop has been discontinued, so the charger is like, you have to good luck finding it. Even the companies would be like, HP is like, yeah, we don't have that. And you're like, why the heck you use proprietary system then? Lol. So I'm really hopeful for the future. Again, it's a bit slow, the European Union thing, but I'm happy with it. So this was my presentation on power delivery upgrades. Hopefully it would have clarified why exactly we have that weird number of 240 watts of power. Hopefully in that sort of scenario you liked it, learned it, enjoyed it. In those sort of scenario, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.